From the human perspective, sea slugs may as well be aliens from another planet. It's hard to imagine what it's like to survive in their liquid world, and the science is just beginning to reveal their bizarre adaptations. But over 3,000 species of sea slugs have mastered this ocean landscape, and the secrets to their success are nothing short of superpowers. Just like snails in your garden, sea slugs leave mucus trails behind them too. This is a sea slug predator called Navinax. Navinax not only leaves a trail, but is highly tuned to follow them as well. This sea slug is a Janalus, and the structures along its body are called serrata. Serrata help a sea slug breathe, digest, and even defend itself. Which is a good thing for this Janalus, because it has no idea it's being stalked. Once in striking distance, Navinax lunges. Like a coat of arms, Janalus flares out its serrata, keeping Navinax from reaching its vulnerable body. With a pause in the onslaught, Janalus curls up into a ball and rolls away. The hungry Navinax is left unsatisfied. Sea slug antennae are called rhinophores and are used to smell the seawater. The black dots you see are primitive eye spots, foretelling light from dark. Their hearts pump blood directly from their serrata into their body. No veins or arteries required. And the serrata, again, are multi-purpose. This Spanish shawl stores stinging cells from the food it eats in their bright orange structures. Amazingly, the Navinax can sense this just by touch. The predator moves on in search of something a little less spicy. Close by, a Hermesenda sea slug has taken a wrong turn. Navinax has picked up on the trail. Hermesenda has stumbled upon a patch of tiny skeleton shrimp impeding its way. Unable to make a run for it, it's no match for the hungry Navinax. Closer to the surface, life seems more slowly paced for this California sea hare. Sea hares love red algae. It's the key to their unexpected superpower, and they eat so much of it that they turn red too. But danger lurks in the darkness, and our sea hare is being watched. On this reef, food is scarce, and a passing sea hare is just too tempting for this lobster to ignore. The lobster drags the sea hare into his cave, and instinctively, the sea hare rolls into a ball for protection. The sea hare reveals its powers. First, the sea hare secretes a substance called opaline. This sticky substance covers the lobster's appendages, flustering it. But this lobster isn't giving up. Stage 2, bright purple ink, derived from the red algae it eats. In a process called phagomimicry, the ink provokes a feeding response in the lobster, enticing it to eat the ink instead of the sea hare. The sea hare may be slow, but the lobster is confused and preoccupied. It eventually makes its escape, leaving the attacker with nothing but a mouthful of ink. Though sea slugs may seem lethargic, that's not always the case. Take this rainbow nudibranch. Its secret lies in its serrata, which are finely branched to absorb as much oxygen as possible. It moves slowly across the ocean floor in search of a meal. On the menu, tube anemones. So begins the climb. Too slow. Success is going to require a little more speed. Starting over, the rainbow nudibranch extends an oral veil from its mouth, allowing it to capture the anemone's stray tentacles without alerting it. Once enough have been gathered, it bites down, getting a free ride down the tube. The rainbow nudibranch will eventually incorporate some of these stinging cells into its serrata and use them for defense. It's this ability of sea slugs to use the tools of the creatures around them that make their adaptations so spectacular. One of the most remarkable examples of this was recently studied by scientist Pat Krug at Cal State Los Angeles. Pat is investigating how these Elysia sea slugs are using chloroplasts from the algae they eat to continue growing with little to no food. To test this, he's been controlling the amount of light exposure on these sea slugs.
So it's been 3 weeks with this slug getting artificial sunlight and this slug being held in artificial shade. And what we can see is that the slug that got sunlight grew a bit more than the slug that was held in the shade.
Pat's experiment proves that these little sea slugs are harnessing the power of the plants they eat to tap into the energy of the sun. Imagine if you could eat some leaves and then for weeks thereafter survive solely off of sunlight. That's what these guys are doing. With over 3,000 species of sea slugs on Earth, who knows what other secrets this incredible group of animals is hiding.
We're fascinated by the T-Rex of the oceans, a beast 3 times longer and 30 times heavier than a great white shark.
How could a shark get this large? What were these massive teeth being used for?
Now, breakthroughs are revealing hidden details about the monster shark's secret struggles.
A race between predator and prey to adapt to be the safe one in the fight.
There are new theories about what caused the beast to vanish from worldwide seas. And mother megalodons started out with many more babies than were born.
We think that Megalodon was cannibalistic, and there's no reason to think that meg pups would have been safe from other larger megalodons.
The pups that emerged were the strongest because they ate their siblings in the womb.
It's one of the reasons that they're able to give live birth at relatively large sizes.
Baby shark may have just taken on a whole new meaning. Megalodon hunted in seas around the world from 23 to 3.5 million years ago.
Its prey lived globally, so wherever its prey were, so was Megalodon.
Dr. Stephen Godfrey is a paleontologist and the curator of the Calvert Marine Museum in Solomons, Maryland. The Meg didn't eye dinosaurs on the beach because those reptiles vanished 65 million years ago.
There's no possible way that Megalodon would have encountered a Tyrannosaurus rex.
The KPG extinction was about 65 million years ago. That is when the dinosaurs went extinct. Megalodon first appears about 20 million years ago. So there's about a 45 million year gap between the last occurrence of dinosaurs and the first occurrence of Megalodon.
Dr. Victor Perez is the assistant curator at the museum. Growing up where Megalodon teeth are found led him to become a paleontologist.
Locally around here, the fact that people can find them and own a piece of that history, I think that drives a lot of that fascination and curiosity.
Megalodon may be extinct, but the monster shark still gets top billing in countless novels and films. Megalodon was a global creature, but one unique location yields an impressive fossil record of the beast.
When Megalodon was alive, this area was a forested coastal plain teeming with life, adjacent to a warm, shallow sea.
The Calvert Cliffs in Maryland were once underwater and reveal much about Megalodon's life story from 20 million years ago until 7 million years ago.
Megalodon teeth are found here on land or in excavation sites because those sediments that preserve those teeth were once ocean bottom, ocean floor. And so as Megalodon was shedding its teeth, living in these coastal plain areas that were flooded, its teeth were sinking to the bottom of those shallow marine environments and being preserved as fossils.
The cliffs reveal that Megalodon evolved over 13 million years. But it's not the color of the teeth that reveals the monster's evolution.
Primarily, the variety of colors you're seeing often has to do with the sediment that fossil is preserved in.
The evolutionary changes are reflected by small wings, or cusplets, on some Megalodon teeth.
They gradually reduced those lateral cusplets, which could be interpreted as something that would just kind of be an interference with cutting. Around 10 million years ago that we stopped seeing the lateral cusplets.
Regardless of when an individual Megalodon lived, it was unique among sharks, both prehistoric and modern. Most reconstructions of the Meg show a supersized, plump great white shark.
I think this is a really good scale rendering of what Megalodon looked like. Notice how bulky its body was and how massive its head and jaws were.
New research suggests that Megalodon had a much broader, dome-shaped head, a shorter, blunt snout, and a flatter jaw than great white sharks. They may have had extra long pectoral fins to stabilize their enormous bulk.
Megalodon was able to evolve to its gigantic size because natural selection sculpted it that way.
Megalodon was probably counter-shaded like great whites to make them less visible to prey. But great whites aren't modern-day small relatives of Megalodon.
When Megalodon was first described, its name was Carcharodon megalodon. And what that name was indicating was that it was thought to be the ancestor of the living great white shark. Since then, we have realized that they are not as closely related.
They are like cousins, but the modern great white did not evolve from Megalodon. In other words, Megalodon is not the ancestor of the modern great white shark.
The two shark species actually lived at the same time, in the same prehistoric seas.
Great white sharks appear in the fossil record about 6 million years ago, so they overlapped with Megalodon for about 3 million years.
Both of these species were likely feeding on marine mammals, so we know that the great white will feed on seals and other marine mammals. And we have evidence in the fossil record of Megalodon preying on marine mammals. We call this convergent evolution.
Some researchers believe that the smaller, more agile great whites were responsible for the extinction of the colossal megs. But Victor thinks it was a combination of factors.
Megalodon being as large as it would require more food than a great white. So just the fact that great whites could survive with less prey gave them advantage over Megalodon. Another theory is that whales and dolphins adapted the ability to go into colder waters, and that Megalodon couldn't tolerate those cold temperatures, so there was a reduction in prey availability. And the third explanation is that when Panama formed, that landmass separated the Pacific from the Atlantic, and people suggested that that interrupted some of the migration routes for Megalodon.
Great whites successfully met the challenges of changing Miocene seas, and Megalodon did not. But the giant sharks and the early great whites did have many things in common.
They're both carnivorous, and they both feed on animals that are too large to swallow whole. So their teeth are specialized at cutting out pieces, so they eat the animal in many bites.
We would describe both of the teeth as cutting-type teeth. They are broadly triangular, they are serrated, so they function for tearing and cutting into flesh very well.
Teeth are almost all that we have left of Megalodon. Like all sharks, their skeletons consisted of fragile cartilage, which rarely survives the millennia.
Sharks have a cartilaginous skeleton, so cartilage like your nose and your ear, the flexible material, it does not readily preserve like bone does. But the teeth of the shark are similar in composition to our own.
Great whites and Megalodon shared saw-like edges on their teeth, with some subtle differences.
Great whites have coarsely serrated teeth that are flattened from front to back, whereas the teeth of Megalodon are very finely and evenly serrated with a massive root, showing that their teeth were very firmly anchored to its jaws.
The robust root probably helps with dealing with the intense pressure when it bit down on a large whale, potentially encountering bone and things like that.
This is a tail vertebra from an extinct dolphin, and we know from its size and shape that it was right down just in front of the fluke, of the tail fluke of the dolphin that propelled it through the water. And what's remarkable about this specimen is that on both sides of the vertebra, there are these deep gouges. The only way that you can get deep gouges like this on both sides of the vertebra, which in a normal vertebra wouldn't be there, would be that this vertebra became wedged between two adjacent Megalodon teeth.
Like white sharks, Megalodon was strategic.
Megalodon's strategy would be to attack the tail of the animal, effectively immobilize it, and then that animal would bleed out, and at that point it would just be scavenging. So there's very low risk of getting injured if that is your strategy.
But was the Meg just a colossal predator, or a supersized opportunist?
Each gouge, though, represents a separate bite by the Megalodon. So it's as though Megalodon is saying to this dolphin, "You are never going to get away from me." In other words, it chased down or ambushed its prey. Now that's not to say that it wasn't also a scavenger like great whites are.
Megalodon didn't limit itself to dolphins.
This is a fossilized sperm whale tooth. There are a series of gouge marks on here. So what this shows is that there was a trophic interaction, a predatory interaction between Megalodon and a sperm whale. This is very aggressive type of behavior by Megalodon to try to kill the sperm whale.
This attack strategy may have seen Megalodon first tear off the victim's fins, leaving it helpless and quickly growing weak enough to consume. It's the same technique great whites use today to prevent being injured by large prey. And like great whites, when the legendary monster did hunt, it didn't always succeed.
This is a dorsal vertebra from a relatively small whale. What this shows is that there was a massive trauma that it experienced where the whole bottom of the vertebra was broken away. This whale was struck either from behind or ambushed from below by Megalodon. But what's fascinating about this specimen is that the whale did not die from this impact. And that is, we know that because of this new bone growth that was attempting to mend this vertebra, make the best of a really bad situation. This vertebra, I think, shows evidence of failed predation where Megalodon was not always successful at killing its prey.
So basically, if the shark bit into a prey item and it didn't succeed in killing it, and then that animal healed, it means that it survived that predation event. So that would tell us that that animal was alive when it happened.
Like other sharks in the same order, Megalodon may have used warm lagoons as nurseries. After giving birth, the mother sharks abandoned their newly minted offspring to the relative safety of these protected bays.
The first ever study that's proposed that Megalodon used nursery habitats was in Panama.
Although most sharks are apex predators as adults, they're fair game when they're little, and just after birth, they're completely on their own. Inlets and bays have plenty of food for small sharks, and larger predators avoid the shallow water. Possible nursery areas for Megalodon may have likely been found in Mexico, Florida, and Chile, as well as Panama, and the research is ongoing.
It has been suggested that the northern end of Calvert Cliffs was also a nursery area for Megalodon.
Great white pups are between 3 and 4 feet long at birth, but newborn megalodons were larger than most adult humans. Baby megalodons faced challenges even before enjoying the warm waters. Megs eating megs may have continued throughout their lives.
Adult megs were probably also cannibals. From time to time, meg teeth are found that show that they were bitten by another meg tooth. The possibility exists that some of those meg-bitten teeth might have come about as a result of meg-on-meg predation.
While the developing megalodons were eating their unlucky siblings, their teeth were developing too.
When you find a tooth with lateral cusplets, it could be a juvenile of Megalodon, or it could be the ancestor of Megalodon. And there is really no way to tell those two apart. And the reason that you see that is because typically as an animal develops, you see evidence of its evolutionary history.
But the megalodon's teeth still reveal the most clues about the monster shark.
The size of the megalodon tooth tells us how large the animal was. There's a relationship between the size of the megalodon tooth and the length of the body.
There are so many megalodon teeth scattered around the world that researchers stay busy.
Like all other sharks, it produced multiple teeth, hundreds of teeth throughout its lifetime, and would have shed those teeth.
So how long did it take a megalodon to grow into a 60-foot-long predator? Researchers at DePaul University in Chicago used CT scans to examine incremental growth bands in a rare megalodon vertebrae. The vertebrae were unearthed in the 19th century in Antwerp, Belgium. Each vertebrae measured about 6 inches in diameter. Based on comparisons to vertebrae of modern sharks, the scientists estimated they came from an individual about 30 feet in length.
Sharks, they have indeterminate growth, which means that they will continue to grow throughout their entire life. The longer their life expectancy is, the more time they have to grow, so the larger they can get.
The new images revealed the vertebrae to have 46 growth bands. These bands could represent years in the shark's life, like tree rings.
When you're looking at tree rings, you're looking at a living thing that is immobile. So there's different growth rates when it's warm versus when it's cold. Most sharks are not immobile. They are moving about to different areas. So the duration in which they are in warm water versus cold water may not equate to a year.
But if each ring does represent a year, then the individual was 46 years old when it died. Extrapolation would mean this megalodon would have been nearly 60 feet long had it lived for 100 years, and was over 6 feet long at birth. The study also suggests that the shark grew at an average rate of about 6.3 inches per year. This proposed growth curve would put its potential lifespan close to a century. As a major predator that lived in the past, Megalodon played an important role in shaping our oceans today. Knowing how the creatures grew, how long they lived, and how their pups survived helps to understand the role sharks play in the context of the evolution of marine ecosystems.
Megalodon was the top marine predator for about 20 million years. Without a doubt, it helped to shape the modern marine ecosystem. It helped to drive a morphological arms race that reverberated throughout the rest of the marine ecosystem.
Despite periodic claims to the contrary, Megalodon is definitely extinct.
If Megalodon was still alive today, fishermen would not be speculating about encounters. They would 100% know whether or not Megalodon was present.
No matter how big and powerful you are, if you can't adapt to a changing environment, you will become extinct.
Every Megalodon tooth that has been found is ancient, and until a fresh tooth, or some other form of proof, is discovered, the ancient beast will stay in the past. But the more we learn about the monster shark, the more our fascination will continue to grow.